Number 9. Okay, so this is going to be a lengthy problem. I want to just kind of give you a little warning. Whenever you see a problem like this with two radical expressions, try to isolate them. Put 1 on one side of the equal sign and 1 on the other. If you do not, then you will have to square this problem 3 times, which will get more work. Right now, as it stands, we will already have to square it twice. But I'm going to show you that whole process. It will be a little bit long, but if we do it correctly, then it'll be worth it, not having to do it multiple times. And I assure you that this is the shortest, most efficient way. So right now I have 2 radical expressions on the same side of the equal sign. I don't want that. Move one of them over. So if you add the square root of x minus 1 to both sides, you will come up with a new expression. This will go to 0. We will have the square root 3x plus 1 equals 2 plus square root of x minus 1. Alright. Now, we're going to square both sides to get rid of this square root. So you isolate one of them. Square this and square this. When you square a square root, it gets rid of it. So on the left side we have 3x plus 1. On this side we actually have to FOIL it out. Now there is a shortcut when squaring binomials. Let me go to some scratch paper because I'm going to start using that from now on. So let me show you what that means. It works with addition, it works with subtraction. If you have a squared, or not a squared, but just a plus b, it could be minus b. I'll do them separately. This is the way that this works. So any time you have 2 terms, raising it to second power. Here's what's going on, and I'll show you with FOIL method as well. You're really rewriting it and then distributing and foiling. The shortcut is you square the first one, so that would be a squared. If there's a number or something else there, square whatever is there and you get that term squared. The next term is you multiply these 2 numbers together, so a and b. A times b would be a times b, and you double it because you would have it twice. So you have plus a times b, and doubling it means multiply it by 2, so that would be doubling it. 2 times whatever you get when you multiply these 2. And then the last term, you would square the last term, so you get b squared. So I'm going to use this shortcut: square, multiply, double, square. Start in the beginning, square it, multiply these and double it, and then square the last term. So here's how this works with FOIL, and it just saves you a little bit of writing. However, if you just rather FOIL it and do that, that works. But just know that when I go from here to here, this is what I'm doing. It's FOIL, just a shorter memorization to get there quicker. A times a will give you a squared, same term. A times b will give you positive ab. So I'm done with a. I did a times a and a times b. Now b times a, same thing. B times a times b. So another positive ab. And as you can see, we have 2 ab's. That's why we double that term, always the case. And then b times b will give you b squared. And when you add the 2 middle terms, a squared plus 2ab plus b squared. Now when I do this, I will try to explain again the process, but I'm going to do this because it saves some writing. especially for really long problems like we're doing. Okay, so back to the problem at hand. So I'm going to apply that little shortcut method instead of writing this down twice, foiling it, combining like terms. You square the first term, so 2 squared, that's how I'll get my 4. Multiply these two terms together. 2 is not in the square root, so it cannot go underneath, it will just go out front. So 2 times this will give you 2 square roots. So I'm going to write that down here small. 2 square root of x minus 1. Well, the formula says multiply these two and then double it. So I have to multiply this 2 times 2. So 2 times 2 will give me 4. So right here I will write down plus 4 square root of x minus 1. And then you square the last term. So when you square the square root, it gets rid of it, and we're just left with x minus 1. So plus x minus 1. So if you want to FOIL it, you should get the same thing. Where did the square root go? Well, when you square the last term, remember square, multiply these two and double it, times 2, right there. And then you square the last term. When you square that square root, it goes away. Alright, now we're going to start combining like terms and isolate this square root. Alright, so over here we have a minus 1, which we combine with that 4. And so that will give us 3x plus 1 equals, I'm going to bring this up front. So 4 square root of x minus 1 plus x. And then this 4 and this minus 1, we're going to combine those. It's going to give us a positive 3. Now we will subtract x from both sides. And then that will give us 2x plus 1 equals 4 square root of x minus 1. That went away, bring down to plus 3. Now we're going to subtract 3 from both sides. That goes away. So now we have 2x, that would be minus 2, equals 4 square root x minus 1. Okay, so we have isolated this square root. Now this 4 out front, you can divide it off, but we will have fractions, and I want to avoid dealing with fractions. So having that number attached to the front is not going to change the problem that much. So that will be, it'll be a lot easier to leave it than it would be to divide it off. So now from this spot, to get rid of this square root, we have to now square the problem again. So I'm squaring both sides. Alright, so when you square, remember that shortcut I'm doing. I'm squaring this. So you got to square both these terms. Square the 2 and the x squared. So 2 squared is 4. And then that's going to give us x squared when you square that. Multiply these two. Now, this is negative, this is positive, so we're going to have a negative 4x. But you have to double it, so it's going to be a negative 8x. Okay? And then you square negative 2, that's going to give you a positive 4. Alright, over here when we square, we just have to square the 4 and square this term. So over here we have equal, we have 4 squared, which will be 16, and when you square square root, it gets rid of the square root, so we have x minus 1. Now we're going to distribute, so we have 4x squared minus 8x plus 4 equals 16x minus 16. Alright, so I'm going to combine like terms, or move everything over so we have everything set equal to 0, and then we will solve our quadratic. So I'm going to subtract 16x, and I'm also going to add 16, so it's going to leave this left side with 0. Just trying to condense some work. So subtracting that because it's positive, So minus 16x, and then add 16. So that goes to 0, that goes to 0. And then over here we have 4x squared. That gives me minus 24x and then plus 20. Alright, I'm going to see if this factors. Hopefully it does, because this is a lot of work already. So I got another sheet of paper because I'm out of room here. And that was the scratch work showing the shortcut. Alright, so I'm going to transcribe this problem here. 4x squared minus 24x plus 20. Okay, with factoring, we want to, if possible, factor out the greatest common factor. So looking at all these terms, they are divisible by 4. So we can pull out a 4. So divide everything by 4, that gives us x squared. Divide by 4, this gives us minus 6x. Divide by 4 gives us a positive 5 equals 0. Alright, so now we have a smaller problem to factor. 1 times 5 gives us 5. Factors of 5 are 1 and 5. We would have to add to get 6, and these guys do add to give us 6. Alright, so we get 4, 2 sets of parentheses equals 0. And then we have x in each, the 1 and the 5 that we found. The first sign is the bigger number, so 5 will be negative. The second sign being positive means these are the same, so this will also be negative. And then when I set everything equal to 0, the 4 is not going to be a factor in changing this, so we just have x minus 1 equal 0, and x minus 5 equals 0. And then when we solve this, we get x equals 1 and x equals 5. Now, a lot of work, but be mindful, as I mentioned in the beginning, if you do not move one of these at the beginning, as we square both sides here, and then later on have to square both sides down here, you will have to do it a third time because it will still have a square root in it. So be aware of that. So we get 1 and 5 as our two solutions. Maybe should check these out. I'm not sure if they will both work, but let's see. When you have square roots, it's better to check them than to just go with the flow. So I'm going to plug in 5 first. So 3 times 5 will give me 15 plus 1 is 16. So I have square root of 16. And then plug a 5 in here as well. 5 minus 1 is 4. So minus square root of 4. Does that equal 2? So square root of 16 is 4. Minus square root of 4 is 2. Equals 2. That checks. And then plug in the 1. So 3 times 1 is 3 plus 1 is 4. So we have the square root of 4. And then over here minus the square root of 1 minus 1, which will be 0. So this gives us 2 minus 0, which does in fact equal 2. So they both work in this case. I just did some mental math. I plugged in the 5 to both, and then I plugged in 1 to both. You can't mix and match. You can't plug 5 here and 1 here. You gotta, if x is 1, then that same x has to be the same on both. So 1 and 5.